There. And there it is. So it was intersecting lines next, I believe. Any idea how you would do these? Can you hear me?
Hello?
Hey, sorry about that. That's what happened.
Fine.
Okay, so I'll try that. Okay. Okay, so try that when you're ready.
Yeah, plus 3, 1, 0. Y so y equals minus a third of x plus 2.
Okay.
And the next one, y equals 2x minus 5. So if it's a sketch, they just want the main points.
Yeah.
So I'll just draw that. So 2x minus 5. So we'll mark the y-intercept at minus 5. We'll just draw a line there and say minus 5.
Sure.
And the next one is plus 2. So we can just mark a point on the y-axis of 2. And then a third, if it's a third, coordinates. Okay, so at the point of intersection, these two gradients will be the same, I think.
The points will be the same.
Yeah, okay, so do we differentiate or
No. You could say they're both equal to y.
yeah, okay. So then minus a third x plus 2 equals 2x minus 5.
Yeah.
Is that right? So then so 1 2/3 of x equals 7.
So when you bring the minus a third x over, it'll become plus.
Okay, so 2 1/3 x, sorry. So
Yeah.
2 1/3 x equals minus 5 equals 7. So x equals 7 over 2 1/3, which is equal to 10.5 here.
I believe it should be 2. So you could times both sides by 2, divide both sides by 7. So instead of writing 2 1/3, I wrote a 7 over 2.
Okay.
It would be 7 divided by 2 1/3, if that's what you were doing.
7 divided by 2 1/3. Oh, okay.
Like divide both sides by 2 1/3.
Right. Okay. Yeah, so 7 over 2x is equal to 7. So x is, you times 7, basically 7 times 2 over 7, so you get 2 there.
Yeah.
So you get the x coordinate and sub that into the first equation, so y equals minus 1/3 of 2 plus 2. Yeah.
No, what did we say x was?
X was 2.
Okay. Maybe use the second equation?
Right, okay, so 2 lots of 2 minus 5. Y equals 2 lots of 2, which is minus 1.
Yeah.
So that means that our set of coordinates would be 2 comma minus 1.
That's it. And so we have to sketch both of these lines. So we only have the y-intercepts for them. So how would we get a second point? Let's say where they cross the x-axis or something.
I'm not too sure, to be honest.
So you for the x-intercepts, you could let y be 0 and find x.
Okay, so 2x minus 5 equals 0.
Yeah.
So then 2x is 5. X is 2.5.
Yeah.
So the coordinates here would be 0, 2.5. So something. So you can kind of mark some average, like where you'd guess the points to be. So yeah.
So you only need 2 for a straight line. And we got the 2 intercepts. So that one is minus 5 on the y, 2.5 on the x. And so we can join those up.
Yeah.
How about the other line?
The cubic graph, but it's a minus, so...
No. This is a straight line graph. There's no x cubed.
Oh, right, so... Yeah, sorry, so... minus 1/3, so plus 2.
And so when y is 0?
Okay, so 0 is minus 1/3 plus 3rd x plus 2. Minus 1/3 x equals minus 2. X is 6. X is 6, so 0, 6.
So that one's 6. And so that one will cross there. Okay. And that's our sketch. So minus 5, 2.5. Okay, so I think what might make this a bit simpler is with the first one. When x is 0, what is y?
When x is 0, okay, so x plus 3y minus 0. So 3y minus 6 is 0. Y is 2.
So y is 2. And then when y is 0?
When y is 0, so that would be x minus 6 is 0, so x is 6.
Yeah, and so you get the same answer. You don't have to make it y equals. So you get 2, you get 6, and then the other one you get minus 5, and we said it was 2.5. And then we join them up and we get the point of intersection. And another thing is for the, when you equate them, you could say, so this one y equals 2x minus 5. So this one you could say x plus 3, 2x minus 5 instead of y. So you still don't have to make it y equals. And so that would be 15 minus 6. So that's 7x equals 21. So that's x equals 3. Is that a different answer or the same one?
I think that's different.
So maybe in the rearranging of the other one, there's a minus sign because it looks like it should be a positive x and positive y from the sketch. So minus. So here's 6. So minus a third x. I'm not sure. Wow, I'll better make sure. Let's see. So this one here. So y equals minus 1/3 x plus 2. So that part's fine. 1/3 minus 1/3 x plus 2 equals 2x minus 5. So 7 equals 2 1/3. 7 over 2, 14. Don't know why that's not working. So for our one, what y would you get if x was 3?
So if x was 3, 3y minus, so okay. Y is 1.
Yeah. And so that there, they're both positive. And so that looks like it's correct. And if we check here, x is 3, y is 1. Oh. So I think in the rearranging of the previous one, something went wrong somewhere. And yeah, so x is 3 and y is 1.
Okay.
Yeah. Any questions there?
Could you go through the kind of the question again? Is that all right?
So I think the big picture is to sketch y equals 2x minus 5 is pretty straightforward because it's y equals. To sketch the other one, you don't need to rearrange it. You could just let x be 0, find y, and then let y be 0, find x. And that would give you the x-intercept and y-intercept.
Okay.
And you only need 2 points anyway, and those are the two most important points. Once you have those, so that's sketch the graph, and then they said they wanted you to give the point of intersection, and it's clearly they're both positive. X is positive, y is positive. So to get the point of intersection, so they did it a different way. My way of doing it is one of them says y equals 2x minus 5. And so in the other one, instead of writing 3y, I wrote 3 times 2x minus 5. because y equals 2x minus 5. So I did it simultaneous equations by substitution.
Okay. I'll just write that down.
Okay.
Why do we do the substitution by how, like, you know, the last step? How does that actually get us the answer?
Replacing y with 2x minus 5.
Yeah.
It's it eliminates the y's. So instead of having two equations with two unknowns, you have one equation with one unknown. They did it a different way. They did, you multiply it by 2 and then simultaneous equations. So yeah, they made them both equal to 0, and then they doubled one of them. So you have 2x in one and 2x in the other. That strikes me as a lot more. It's just a method of simultaneous equations. For simultaneous equations, when one is already y equals, it's simpler to just sub that into the other one. And you go from having x and y to just x and more x, so you can solve it.
Okay.
So that's the basic idea. Any other questions with that one?
No, I got that. Thanks.
Okay. So this one, they want you to just plot the two. So how would you do this one?
I'll just write the question down.
Okay.
Okay. Minus 4. Could I just go and get my math set? It's just in the cupboard next to me. Is that all right?
Yeah.
So this is kind of a bit easier. So I'll just convert this. x, if I rearrange the first equation, y equals minus x plus 2. So I'll just get a table of values. So y is minus x plus 2. So y equals, for minus 4, 6. 6. X is minus 4. 6. For minus 3.
So what type of graphs are these two?
They're both like straight lines.
Okay, and so really you only need the first point and the last point to draw a straight line.
All right. Okay. So yeah. Okay. For the last point, then that would be minus 4 plus 2. So that would be minus 2. And then for the next graph, 4y equals x minus x plus 4. Y equals x over 4 plus 1. So for the first coordinate, minus 4 over 4 is minus 1 plus 1 is 0. First point would be like minus 4, 0. And the last point would be 2. 4, 2.
Okay. And so you would sketch those, or you would draw them.
Yeah.
Okay.
So the point of intersection is...
And it's not going to be an easy number.
Would it be 1, comma... 1,1.3.
So I'm not sure. See, I can only really sketch it, but this is what the graph would look like. And so how can you use that to estimate the solutions?
So it will be less than 1, right? So, yeah, mine's a bit less than 1. So I'd say about, yeah, that's gone to 0.1, 0.9, 0.8, and then 1.2, I'd say 1.2.
And that looks about right. So 0.8 and 1.2. And they did it this long way, which was for, well, not too long actually. They did minus 2, 0, 2. So they only used 3 points. Yeah. So you only need 2 points, and you could use a third to perhaps confirm that it's correct. Yeah, use the first and last, and then just check that it has the y-intercept you're expecting, maybe. And so for this type, this is you have to, it's like an accurate drawing, and so you do it by literally, you solve it by drawing it as opposed to sketching, and then just reading it off from the graph. Any questions there?
No, that's fine.
Okay. And if you know that they're both linear, that they're both straight lines, then you can just you have to do every x coordinate. You can just do first and last. So is there let's see, solve these pairs by plotting the graphs. How would you solve these just by algebra? Part 1.
Part 1. X is 3y plus 1. Y is x minus 1. So you'd say that you could substitute the y for x minus 1. So x equals 3 times x minus 1 plus 1.
Okay.
So x is 3x minus 3 plus 1. 2x 2x minus 2 is 0. So 2x is 2. You could say that x is 1.
Mm-hmm.
Then you say x is 3y plus 1. So 1 equals 3y plus 1. 3y equals 0. So y is 0 over 3, which is also 0.
Yeah.
Okay.
So for the second one, you see, you're doing it a more difficult way. So one way is you put in x minus 1 in for y. What if you eliminated it the other way around and you kept the y's and you got rid of the x? How would that work?
So you'd say that y equals 3y plus 1 minus 1?
Yeah. 3y.
Okay.
And so maybe that would be a bit easier?
Yeah, that looks a lot easier actually. So
no, that's fine. You'll get the same answer. And what else was I going to say? Yes, for this one, you got x equals 1. Substitute that into the second equation.
So y equals minus 1, y equals 1 minus 1, which is 0.
Yeah, so this one is already y equals. You're trying to find what y equals, and so that's the one you would go with.
Okay.
Okay, so that's substitution. I'm happy enough there. So you're doing it. Okay, what would be, so part 3, what would be step 1 for using algebra?
Y equals 2x minus 4. And then you just sub that into the y value on the second equation. So 3x plus 4 times 2x minus 4.
Yeah, I'm fine. I'm happy with that.
Yeah.
And how about the very last one, part 4?
Okay, so I think, yeah, you'd basically just have it, one of them to be y equals, so you could say that.
So that's the easiest way when one of them is already y equals or x equals. Here it's just it's in the form of a simultaneous equation.
Okay, yeah, so it might be easier just to add the two equations to get the x.
Correct. Yeah. Yes. Okay, so okay, go on. What would you get there?
So you get 10x equals 5, so x is a half.
Yeah, and so for that one, x equals a half. And then you'll be fine from there.
Yeah.
They wanted you to draw these. I think that the actual questions, they won't ask you to do that. They'll ask you to perhaps draw one graph and then use that to solve the simultaneous equations, but not in a case like this where it's so obvious. Okay, I'll let you read this. Tell me if this is worth doing.
I think I can probably do that in my own time.
Yeah, so the only trick there is the area of the triangle. So intersecting lines, x a half or tick.
I think that's a tick.
Yeah. Okay. So this next one is kind of tricky. See if you can figure it out. So you're given two coordinates. You have to do this.
Okay, so would we add the two coordinate sets and then multiply that by 2 over 5?
So 2/5 is the right idea. So what would be 2/5 of the x of the?
Oh, do you mean the difference?
Yeah.
4 to 19. Okay, so that would be 2/5 times, what's that, 15? So that would just be 6 as our x coordinate.
So it would be 6 across from the starting point.
Oh, right, so that would be 10.
Yeah. So it's 4 plus 2/5 of the difference. And then how about going up?
So that's 20. So 2/5 of 20 is that's 8. You're adding 8. So then 7 plus 8 would be 15. So 10, 15 would be the coordinate.
15. So it looks like it's 10, 15. And that's 2/5 along the x and 2/5 up the y. And there we go, 10 and 15. So there's this crazy formula you can use. I think our way is probably the easiest. Just 2/5 of the difference plus the starting point.
Yeah.
It's a bit more understandable. Okay, how about this one?
Just before that, could I close the window? Is that all right?
Sure, yeah.
All right. AB is a straight line. Is minus 3 comma 2, and B is something like 419. In my head. Okay, so minus 3, and that would be 4. That would... This is not bad. Minus 19. So the difference between the x coordinates would be 7, and the ratio is 4 to 3. So we do 4 over 7 multiplied by 7, and we get 4. So we're adding 4 to the original x value. So that would be 1.
Mm-hmm.
1 is 1. And then 2 to 19 is minus 21. So 4 over 7 times minus 21 is minus 12. So we're minusing 12 from the original y. So that would be 2 minus 12 is minus 10. So our coordinates would be 1 comma minus 10.
Well done. Any questions about that?
No, I got that. It's fine.
So 1 minus 10. So my method is actually quite unusual for that, but I'm glad I've used it instead of their one. Let's see. Yes. This time you're given a point. How would you do this?
In figure 5.13, PQR is a string. I'll just write the question down. So PQR is a straight line. Yes. Okay, so you're given the ratio, so that would be 2 over 7. Yes. Okay, so I draw the triangle. I'm still kind of unsure how I could approach this.
So do it exact same as the last one, except this time use x instead of the actual original x coordinate.
Okay, so 2 7 times x equals...
No. It was 2 7s times the difference.
Okay, so times the x minus 2? Or
what if x was 0? Let's say x was -1. What answer should you get?
This is -1.
Basically, second minus first.
Okay, so that would be -2. Wait, so 2 minus x.
Yeah, 2 minus x. So it's the ratio times the difference, and then what would you do once you get that?
So we'll say that equals to -2.
But there's something missing. So that gives you how much it's going to move across. On our previous one, what was before the fraction? So what's before the fraction each time?
Not
starting point. So in this case, it was -3 plus that, and then the other one it was 2 plus that.
Yeah. Sorry. So okay. So that would be the starting point is 2 minus x.
No, that's the difference.
The starting point is x.
Yeah.
Plus 2/7 times 2 minus x.
And so now you would try to solve it.
That equals to -2. So that is x plus 4/7 minus 2x over 7.
Mm-hmm.
2. So x minus 2x over 7 is -18/7.
It might make it easy to multiply everything by 7.
Yeah, okay, so x plus 4. So 7x plus 4 minus 2x is 14. So x is so 5x is so x is 3.6 minus 3.6, and then we minus the this to the because the x value is going down by minus 3.6 to get that -2. We'd add the minus 3.6 to minus 2.
No, I don't believe so. That's what x is.
Oh yeah, because we add the. Okay, so x is minus 3.6. Is that the coordinate then?
So then now we need the y coordinate.
Okay, so we're given 5, so y plus -3 minus y. Y plus 2/7 times -3 minus y equals -3.
No. Equals. What did our last one equal?
That is 5, sorry. Yeah.
And so, yes, 5.
Yeah, because that's the midpoint type thing. So y is -6/7.
And if you wanted at this point, you could multiply everything by 7. It's up to you.
Yeah. Well, I've got it expanded now, so I might multiply.
Okay, yeah.
So I've got y minus 6 minus, so 7y minus 6 minus 2y is 35. So 5y is 41
Mm-hmm.
is 8.2.
8.2.
So that's our coordinate there.
Yes, minus 3.6 and 8.2. So essentially just sub it into the same formula that we used and rearrange to solve.
Yeah.
Any questions about that?
No, that's fine.
Okay. Let's see if this is not correct. Minus 1225. That should, let's see. So the problem is they're using a totally different formula. Let's see. So minus 2 equals, so we had the same thing, minus 2 equals. Yeah. And then they found it using a different formula. Let me just make sure. So 2 is to 5. Oh, of course. It's 2 is to 5, not 5 is to 2.
2 is to 5.
So because we were looking at it backwards.
Yes, so
Okay. So it would just be 5 sevenths instead of 2 sevenths.
Right, because that's the ratio, yeah. Because we did it, yeah, because I did it the other way around. Okay. Yeah.
Okay. Something to watch for. So I suppose because it was backwards. Yeah. Okay. Let's see. So each of these, in each part, AB straight line, work out the coordinates of C. AC, BC. I don't think these will give you any problems, or if you want to try them, it's up to you.
Will I try number 5?
Yeah.
One.
Yeah.
That's A is 0, 6. I'll just draw these. So 0, 6. Then 0 minus 6. B is minus 18. Minus 18 minus 15. A to C. A to. Oh, that's okay. So I've just drawn the line, with B being like. So yeah, so I just drew the line now. Okay, so we want the B. So the x coordinate here is 0. 0 plus what's this? 5 over 9 times. It's 5 over 9 times 0 again. So that would be.
What's the difference?
Oh, minus. So it would be minus 18 minus 0. So that would just minus 18. So there's 0 plus 5 over 9 minus 18, which is. Minus 10.
Okay.
x coordinate is minus 10. The y coordinate is minus 6 plus 5 over 9 times minus 15 minus 6. That's minus 6 plus 5 over 9 times minus 21. Yeah, 21, so that is... That's minus 53 over 3.
Okay.
So I'll just leave it as a fraction.
What would it be as a recurring decimal?
That is minus 17.6 recurring.
Okay. The reason why I say that is because if you had to put it on a graph, you'd put it between minus 17 and minus 18.
Okay.
Minus 53 over 3, you might not be quite sure where to put it. Okay, any questions there?
No, I think I got that now.
Yeah, so it's pretty straightforward when they're linear like that. Okay, so let's see this one. DEF is a straight line. D is that. E is that. Find F. D is that. E is that. So sometimes they leave out, they give you the, you know, the middle, the thing in between, and you have to find. So I think these two in the middle are the only ones worth trying.
Okay. Should I try both of them or one?
I feel like try one.
Yeah, okay, so I'll try part 4. So E is 2 minus 8. F is 7 minus 19. Minus 19. And D to E to E to F is 3 to 5.
So what would be this? So D to E is 3.
Yeah.
E to F is 5.
That would be 3 over 8 and then 5 over 8.
Yeah.
The ratios. So that's, we're given D, we're given E as well. We need to find F.
No.
Or are we? Wait.
We're not given D. Part 4?
Oh yeah, sorry. So, that's, yeah, okay. So that would be 2 plus 3 over 8 times...
No. So because D is the beginning, we could call that X and Y.
Okay. Oh, because coordinate E is 2 minus...
Yeah.
Oh, okay, right.
So that's why I did this sketch this time, just so we...
Okay. So that would be X plus 3 over 8 times 7 minus X equals equal to 2. So X plus...
No. Yeah, it is equal to 2, yeah.
Yeah. So X plus 21 over 8 minus 3X over 8 is 2. 8X plus 21 minus 3X is 2. 5X is...
Hang on, it's not equal to 2. What's it equal to? You multiplied everything by 8?
Yeah, sorry. 16.
That's it.
Equals 16, so... 5x is minus 5, so x is minus 1.
So x is minus 1. Okay, and then try to find y. Okay, I'm in the front room. I'm just
Sure, thanks.
You can come in, sit on the couch.
So yeah, so I got y plus 3 over 8 times minus 19 plus 3y equals minus 8. So y equal y plus might just be multiplied all by 8 first. So 8y plus 3 lots of minus 19 plus y is minus 16. 8y plus 3y is minus 57. So 8y 3y equals minus 16 plus 57. So 5y equals 57 minus 16, which is 41. So y is 8.2.
Okay, let's see. You have minus 64. Sorry, over on this side gives you minus 8. If you multiply everything by 8, that would be minus 64.
Okay. Yeah. Right, so minus 64. So 57 minus 64 is minus 7.
Yeah.
So we have 5y is minus 7. Y is minus 7 over 5. I'll write that as a number, which is minus 1.4.
Yeah, that's it. And so it's the coordinate minus 1, minus 1.4. Any questions there?
No, that's fine.
Okay, well, yeah, that's that. How did you find that, Stefan?
I think it's kind of easy now, like just following the method, basically.
Yeah. And so, any idea what you want to do next time, or just continue?
I think we can continue, but I was thinking because I've got the maths challenge on the 6th of November.
Mm-hmm.
Do you have any like availability to do 2 more like 1 hour long lessons, like one this week and one next week? Is that all right?
Yeah, a sec.
Yeah.
So, anything you see there that works for you?
No. I think probably next Friday. Oh no, this Friday at 11 looks good. Yeah.
AM?
Yeah, AM. Yeah.
Okay. And then the same, and then the
Same
same thing next.